Some stories sound too wild to be true, like the Beipanjiang Bridge in China. It hangs in the clouds, crossing a canyon so deep that people once thought it was impossible to bridge. What used to be a 4-hour dangerous journey now takes a minute. This is the highest bridge in the world, over 1,800 feet above the river. Imagine building in a place with high winds, thick fog, and earthquakes. Yet, they did it. Workers faced the elements daily, suspended over a chasm, fighting for every inch. This was more than engineering, it was courage and grit. One mistake and the whole thing could collapse. The bridge connects two provinces and changes millions of lives. It's a symbol that the old limits don't apply anymore. With enough willpower and smarts, you can build right over mountains. It's the kind of project that makes you wonder, what else is possible? For engineers everywhere, it's a challenge to dream bigger. Somewhere, on the other side of the world, they aren't just dreaming, they're building. The Beipanjiang Bridge isn't just steel and concrete, it's proof that impossible is just a suggestion. It forces us to rethink what we believe can be done. When you see it, you realize the future is already here. The only question is, are we ready to catch up? Or will we just watch as others build the world of tomorrow? The Shanghai Tower isn't just tall, it's a vertical city. Its twisting glass form rises over 2,000 feet, the second tallest building on Earth. Most skyscrapers fight the wind, this one dances with it. The spiral shape reduces wind load by 24%, saving millions in materials and making the building safer. That's smart engineering, solving problems with elegance. The elevators are among the fastest in the world, shooting you to the 118th floor in under a minute. Inside, the tower is divided into 9 sky lobbies, each a neighborhood in the sky. Shops, restaurants, gardens, community, not just offices. It's a futuristic, self-contained world. While others patch up old infrastructure, China is building the cities of tomorrow. The Shanghai Tower is more than a building, it's a statement. It shows what happens when you combine ambition with innovation. It's a reminder that building smarter is just as important as building bigger. The tower's design tricks the wind, saves resources, and creates a new way to live in the sky. It's a different mindset, a different scale of ambition. For engineers, it's a challenge. Are we thinking big enough? Or are we just building what's safe and familiar? The Shanghai Tower proves the future belongs to those who dare to rethink the rules. It's not just about height, it's about vision, and in Shanghai that vision touches the clouds. The question is, who's next? Stuck in traffic? Delayed flights? China's answer: HighSpeed Rail. Over 25,000 miles of track connect nearly every major city, built in just a decade. These bullet trains glide at over 200 miles per hour, shrinking cross-country trips from a day to a few hours. The Shanghai maglev levitates on magnets, hitting 267 mph, teleportation almost. The scale and speed of construction are staggering. While others debate and delay, China just builds. High-speed rail has transformed how people live and work, connecting communities and boosting growth. It's efficient, clean, and fast. For American engineers, it's both inspiring and frustrating. It shows what's possible when infrastructure is a true priority. While we talk, others are building the future. The question is, will we catch up or keep waiting? Why do these Chinese mega projects shock us? Maybe because we used to be the world's builders. We built the Hoover Dam, the interstate, skyscrapers that touch the sky. We put a man on the moon. But now, building anything big in America is a battle, against red tape, lawsuits, and endless delays. Projects stall for years before breaking ground, costs balloon, and technology gets outdated. Our roads and bridges are aging, our airports feel stuck in the past. Engineers spend more time on paperwork than on solving problems. We've become risk-averse, more focused on avoiding failure than achieving greatness. When American engineers see China build a massive bridge in 3 years, it's a shock. It's not a lack of skill. Our engineers are world-class. What's missing is opportunity and national will. It's like running a race with obstacles while others sprint on a clear track. The difference isn't talent, it's the system. And that's what makes these projects so surprising. How does China build so fast? It's a mix of top-down planning, political will, and relentless innovation. When a project is a priority, funding and permits appear almost overnight. No decade-long debates, just action. Prefabrication is key. Huge sections are built in factories, then assembled on site like giant Legos. Custom machines like the Iron Monster move entire bridge sections in one go. They embrace new tech and aren't afraid to experiment on a massive scale. Rapid cycles of building and learning drive constant improvement. A massive skilled workforce and domestic manufacturing keep everything moving. Of course, speed has costs. Safety, environment, and displacement are real concerns. But from an engineering perspective, the ability to mobilize and execute at this scale is unprecedented. It's a system built for speed and ambition. China's approach is changing the global benchmark for what's possible. The world is watching and taking notes. The question is, can others adapt, or will they be left behind? In China, the future is built at breakneck speed. The Three Gorges Dam isn't just a dam, it's an inland sea held back by human ingenuity. It's the world's largest power station, with enough concrete to alter the Earth's rotation. Its main goal, control the deadly floods of the Yangtze River and generate massive clean energy. Building it meant blocking a powerful river, excavating millions of tons of rock, and relocating over 1 million people. The dam's ship lift is the world's largest, hoisting 3,000-ton vessels over a 600-foot wall in 40 minutes. It's a feat straight out of science fiction. For American engineers, it's awe-inspiring and controversial. We haven't attempted anything this big since the Hoover Dam. The environmental and social costs would make it nearly impossible in the U.S. today. The Three Gorges Dam is a bold calculation, monumental benefits, monumental consequences. It's engineering that tames nature and redefines what's possible. China's land reclamation projects push engineering to the extreme. In the South China Sea, they've turned reefs into artificial islands, complete with harbors, buildings, even airstrips. Fleets of dredging ships suck up sand and build new land, layer by layer. Once above water, the land is stabilized and protected from erosion. It's a complex, high-stakes process, building on unstable foundations in a harsh ocean. The speed and scale are unprecedented. While controversial, these projects show a willingness to reshape geography itself. For engineers, it's a jaw-dropping display of capability. If land is needed, they make it. It's the ultimate statement: we won't be limited by nature. So, what do we do with all this? Get discouraged? No, we get inspired. These projects are a wake-up call, a challenge to dream big again. Competition pushes us to innovate and question old ways. The spirit that built the Brooklyn Bridge and Golden Gate wasn't about being second best. We have the talent and know-how, we just need the will. Engineering isn't a zero-sum game. Breakthroughs in one country can benefit the world. We should share ideas, celebrate achievements, and work together to solve big problems. Progress is progress. A new bridge, a clean dam, a fast train helps everyone. Let's look at China's feats with respect, not envy. Let it spark our own ambition. It's time to roll up our sleeves and start building the future again. The world is waiting. Are we ready to answer the call?